Hey, so we're going to try a harder one now. So you're going to pause and list all of the factors for 40, for 60, and for 24 and see if you can find their GCF. So go ahead and do that and come back and check. Hey, 40 has 1 and 40, 2 and 20. I know 3 can't, 4 and 10, 5 and 8, 6 can't, 7 can't. There's 8. So I know I'm done. Hey, 60 has 6 pairs of factors. Were you able to get them all? So 1 and 60, 2 and 30, 3 and 20, 4 and 15. That's one a lot of people usually forget. 5 and 12, and 6 and 10. That one is not popping up like my other one. So 6 and 10 there. Hey, 24 has 1 and 24. 2 and 12, 3 and 8, 4 and 6. So I'm looking for the greatest number they have in common. So I know that on 24, the biggest number is 24. So there's no way it could possibly be 60. And there's no way it could even be 40. So I'm going to use the smallest number and go backwards on its list to check. So do they each have 24? Nope. Do they each have 12? 12? Oh, no, 12 there. Do they each have 8? Oh, no, 8. So it's not 8. Do they each have 6? And 6? Oh, no, 6 there. So now I'm going to go to the next number, which is 4. Here's a 4, 4, 4. So their GCF is 4. Hey, so that's a lot of work sometimes, and it can be easy to make mistakes like on the number 60 when we're trying to list all of the factors. So here is another way that you can find factors. It's called using a factor tree. So we're going to take a look. So what we're trying to do is we are trying to find the prime numbers. So prime numbers are things like 2, 3, 5, 7, 11, 13. Those are the first 6 prime numbers. The only numbers that can make them are 1 times 2, 1 times 3, 1 times 5, 1 times 7, 1 times 11, 1 times 13. They do not have any other whole number factors. So we are going to start, and we get to pick any numbers that we know make 60. So I'm going to start with 6 and 10. You just pick any ones you know. I'm actually going to do another problem over here of 60, and I'm going to pick something different that equals 60, and we'll see how our answers turn out. So I'm going to pick 4 and 15 here. So 6 is not on my list, so I need to keep going. So 2 times 3 is 6. So the numbers 2 and 3 are on this list down here. So I'm actually going to put a box around them to say these numbers are done. So the number 10, to get 10, I would times 2 and 5. Well, those are both also prime numbers. So I put a box around them. So be sure you're doing this with me on your paper to practice. So 2, 3, 2, and 5 are these prime numbers. So let's try doing 60 a different way and see what answer we get. So the factors to make 4 are 2 and 2, and 2 is a prime number, so I box them up to say those are done. And then to make 15, I have 3 and 5, and those are both prime numbers, so I'm going to box those up as well. So I can see here 2, 2, 3, 5. Here's 2, 2, 3, 5. So even doing 60 a different way, I came up with the same prime numbers. Okay, so let me get this out of the way here. And let's try this number 81. So go ahead and think of 2 numbers you can multiply together that equal 81. So I thought of 9 times 9. 9 is not a prime number. There's more factors I can break it down to. 3 and 3. And now 3 is a prime number, so I can box those up. And same thing here. 3 times 3 is 9. Box them up. Now, all the numbers across the bottom are boxed up. So what we're going to do now is we're going to look for any numbers that are in the boxes that are matched up. So here's a 2. Do we have a 2 over? And it has to be in the opposite problem. So I know there's a 2 in the 60, but it has to be from the other problem. So there's no 2 over here. So I do not need my 2's. 3, 3. There is a 3 in both of them. So I'm just going to write it down below. And I've used that. So that one's done and that one's done. So we have a 5 over on both sides. We do not. So even though there are more 3's, they're not in opposite problems. So we can't use them. They are not helpful to us right now. So the GCF of 60 and 81 is 3. So rather than having to list out all of the factors for 60 and all of the factors for 81, you just do a couple problems and you see what they have in common. If they have more than one number in common, so let's say it had a 2 in common and it had a 3, you just multiply those and that would be your GCF. So let's try another one of those. Okay, 72 and 108. So 72, let's make sure you're writing these down with me to practice. So I know 8 times 9 is 72. So down here, I'm just going to list those prime numbers, 2, 3, 5, 7, 11, 13. So those are the main numbers that I'm looking for. There are many other prime numbers that can keep on going, but we're trying to pretty much get it down to these smallest prime numbers. So I know 8 has more factors. 2 times 4 is 8. 2 is prime, but 4 has more factors. 2 times 2. So I'm going to box those 2's up there. So my 8 is all done. Everything is boxed up. To make 9 is 3 times 3. 3 is a prime number, so I'm going to box those up. Okay, so the number 108, that's a fairly large number, and I don't know all of its factor pairs. I don't even know how many factor pairs it has. Probably quite a few. It's an even number, it's pretty big, so that'd be kind of a lot of work to figure those all out. So instead, I can just think of 2 things that equal 108. So I know this number is even. So I know 2 has to go in there. So I can't think of some things off the top of my head that equal 108, but I know 2 goes in there. So then I can take 108 and I can just quickly divide it. 2 goes into 10 5 times and 2 goes into 8 4 times. So my other factor is 54. That's a much better number to work with. So my 2 is done. Look at that. So let's do this 54. We need to think of 2 factors that together multiplied equal 54, 6 and 9. 6 times 9 is 54. So I need to keep going on 6. 2 times 3 is 6. And then I'm going to box those up. And then 9 has 3 times 3. And now 3 is prime and I can box those up. So all of the bottom numbers are boxed. So now we're going to look and compare and see what numbers we have in common. So 2 and a 2. So yes, I'm going to write that down. Hey, here's a 2. Here's another 2. So I'm going to write the next 2 down. Here's a 2. Do we have one over here? Nope. So I can't use that one. So now let's look for a 3. Oh, here's a matching 3. Let's write that down. And here's a 3. And here's a 3. So we do have this last 3 left over, but there's not another one to match it up. They each have to have their own match. So now we're going to do 2 times 2 times 3 times 3, and that is going to tell us our GCF. So 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. So the number 36 goes into 108 is what that means. And it also goes into 72. So the biggest factor that goes into 72 and 108 is 36. Okay, so there's a couple different strategies you can use to find the GCF. You can either make a list, or you can use the factor tree and find the prime factors, match them up, and multiply any matches. Okay, let's